If the sun failed to ignite, Earth would not freeze in the dark. It would never be built at all. 4.5 billion years ago, the exact atoms destined to become your body, the oceans, and the Earth's crust were suspended in a massive, dark cloud of gas. To force a cloud like this to collapse into a solar system, an external shock is required. Typically, that comes from the violent explosion of a nearby dying star, a supernova, slamming into the gas. But imagine a timeline where that shockwave misses. The cloud, containing one solar mass of material, is left undisturbed in the cold. Because that initial spark failed, the entire gravitational and mechanical chain reaction required to construct planets is entirely aborted before it begins. Over the first 1,000 years, this undisturbed cloud remains locked in a state of hydrostatic equilibrium, a perfectly balanced, stable state resting near absolute zero. In a typical system, planetary construction absolutely requires Keplerian dynamics. This is the mechanism where the massive gravity of a central star pulls the surrounding gas and dust into highly organized, sweeping orbits. Without a central mass, the Keplerian frequency drops to exactly zero. The orbital velocity field completely disappears. With no vertical gravity pulling material inward, the gas expands outward in a chaotic mess, refusing to settle into a single plane. Compare that to how a solar system usually forms. The matter concentrates heavily at the center, forcing the surrounding material into a flat, rapidly rotating protoplanetary disk. Without the immense gravitational anchor of a central star to wrangle the gas, constructing the structural foundation of the solar system, that spinning disk, is physically impossible. Jump ahead to year 100,000. Normally, a young protostar would be generating a massive thermal gradient, radiating intense heat deep into the surrounding space. Notice the frost line, the thermal boundary separating the hot inner rocky zone from the cold outer icy disk. But in our alternate timeline, the central heat source is completely absent. The cloud's temperature remains near absolute zero, permanently erasing the frost line. At these extreme temperatures, every volatile compound, water, ammonia, and methane, freezes entirely onto the surfaces of microscopic, highly porous dust grains. These thick layers of ice trap heavier materials like iron and silicates inside. There is no high-temperature melting to separate the heavy metals from the lighter rocks. Active planetary geology absolutely requires intense heat. Without a star to bake the inner solar system, Earth's future oceans and crust remain permanently locked together as a microscopic, frozen fog. By year 1 million, standard solar systems enter a crucial building phase. Dust grains drag against each other, clumping together to form pebbles, and eventually massive planetesimals. This process relies on a mechanism called streaming instability, which is driven by the precise difference in speed between the slower-moving gas and the faster orbiting solid matter. In our starless cloud, there is no central gravity well to pull solid matter into orbit. That means there is absolutely no difference in velocity between the gas and the dust. Radial drag is zero. Without that drag, particles fail to cluster or collide. Every piece of solid material in the cloud is permanently trapped below a centimeter in size. Planetary growth completely halts. Eventually, a star's solar wind would blow the excess gas away. Lacking that wind, these tiny suspended particles remain permanently smothered in an ocean of primordial hydrogen and helium. An Earth-sized rocky world cannot assemble itself in the dark. It strictly requires a massive central star's orbital forces to sweep, sort, and compress dust into a planet. Let's pull focus outward. Between 10 and 100 million years, our dark, inert cloud continues its slow, unguided orbit around the Milky Way. The galaxy is an incredibly violent environment. The inert presolar cloud is constantly subjected to harsh tidal forces and galactic shear from the massive structures moving around it. Eventually, intense stellar winds and shockwaves from massive, distant stars collide with our unprotected cloud, violently tearing its gas and dust apart. The raw materials meant for Earth, the iron for its core, the silicon for its crust, and the water for its oceans, are shredded and scattered back into the deep interstellar medium. The sun is the absolute mechanical architect of our world. Without its precise birth, Our atoms are reduced to nameless ghosts, drifting endlessly in the galactic void.